Hi, and welcome to a video talking about the derivative power rule. So, in Calculus 1, we've learned so far about what a derivative is, and we've learned that it's the rate of a change of a function, right? It's essentially the slope of a function. So what does that even mean? So that means that at a specific point, the rate at which a function is changing is equal to that function's derivative. And so something that we want to know is, how do we take the derivative? And so, if you'll remember, we notate the derivative with this prime symbol right here, okay? And so, let's say we have a given function, which is x to some value n, right? And we want to find the derivative of that function. So, the power rule of derivatives states that the derivative of x to some power n is equal to that n multiplied by the x to the power of n minus 1. And so, essentially what this means is that, let's say we have some function f, which is equal to x squared. That function's derivative is going to be n, and remember our n here is 2, so this is going to be 2 times x to 2 minus 1, which equals 2x. And so the function x squared's derivative is going to be equal to 2x. And so let's go ahead and try out a few problems here. So let's say we're given the function g of x, and that's equal to 4x plus 7. So let's find g prime of x. So remember, if we're using our rule, we have x to some power n, and let's assume our power n right here is 1. So what we're going to do is, we're going to multiply by 1, so we're going to get 4 times 1. We keep our x, and then we multiply the exponent right here. We subtract the exponent by 1. Right? And then constant, let's remember the constant of the derivative of any constant is just 0. Alright? And so this implies that the derivative of g of x is equal to 4 times x to the 0, which, remember, anything to the 0 power is just 1, so this is 4. Alright, let's take a look at another one. Let's say we're given the function g of t, and it's equal to 5t plus 4t squared. Alright, and let's find the function's derivative. So doing the same thing, we're going to keep our constant right here, because it's multiplied by a variable. We're going to multiply by the 1 that's up here, right? And I'm not going to put that, but let's just imagine that we have multiplied by it, right? And then we're going to go t to the 1 minus 1, which is t to the 0, which is just 1. Alright? And now we're going to keep our 4 for 4t squared. We're going to multiply by our n value of 2. We're going to keep our t. And then we're going to subtract 1 from the 2, which is just 1. Alright? And so this implies that the derivative of g of t is equal to 5 plus 8t. Alright? Let's try another one. Here we're given the function f of x is equal to x to the 75th power minus x plus 3. Alright, and we're asked to find the function's derivative. So we're going to do the same thing here. We have an n value of 75 right here. We're going to multiply by that, keep our x. We're going to subtract 1 from that, so we're going to get 74. We have an n value of 1 over our negative x right here. So we're going to bring that out front, which is just 1, so we're not going to put it. And then x to the 0 is just 1, so we have minus 1, and then plus 3, remember all constants go to 0, which implies that the derivative of f of x is equal to 75x to the 74th minus 1. Alright? I'll give you a little bit of time on this one. Okay? We're given the function f of t, and it's equal to t cubed plus e to the 3 power. And we're asked to find the derivative of f of t. And so, for this first term, we're just going to use the same power rule. We have an n value of 3, so we're going to multiply by 3, keep our t, and then we're going to do 3 minus 1, which is going to be 2. And now right here, you might be thinking to yourself, oh, the derivative of e to some number, x, is equal to e to x, right? Well, in this case, we have an actual number instead of a variable, instead of t in this case. And remember, e to any number, prime, is just 0 because any number to prime is just 0, right? And e to some number is just a number, okay? And so we're actually going to have 3t squared plus 0 right here, which implies that the functional's derivative is equal to 3t squared. Alright? Last problem right here. This one's a little tricky. I'll give you some time. Alright, so we're given a function y is equal to 2x plus the square root of x, okay? So first thing I'm going to do is rewrite this as 2x plus x to the 1/2 power. Just makes it a little bit easier for me to see. So first off, we're going to start with 2x. And remember 2x, we have a power of 1, so we're going to multiply by that 1, and that gives us 2. X to the 1 minus 1 is 0, which is just 1, so we're just going to have 2. Alright, and so here we have x to the 1/2. So let's start off, and let's just subtract 1 from that. So that's going to be x to the 1/2 minus 2 over 2, because remember 2 over 2 is just equal to 1. And let's not forget to multiply by our n value up front, okay? And so this is going to imply that y prime is equal to 2 plus 1/2. We'll bring the 1/2 out front just to not confuse anybody. And we get x to the negative 1/2, all right? And now in some cases you can stop right here, but I'm going to continue simplifying further. And this is going to give us that y prime is equal to 2 plus 1 over 2 to the square root of x. Because right here, we have a value of negative 1/2 over the x exponent, which is going to be in the denominator, because remember from our algebra rules, a negative exponent, you bring it into the denominator, and then a power of 1/2 is going to be a square root. All right.